This is Josh White from JW Math Tutoring. In today's video, I'm going to cover linear paper practice test 4 math section, specifically the unique questions that do not appear on any of the Bluebook practice tests. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Before I get started on going through the unique questions from linear non-adaptive paper practice test number 4, we just want to mention a couple things. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, as I mentioned, these are the unique questions to linear paper practice test 4. In other words, these are the questions that do not appear on Bluebook practice test 4. So by doing these questions, you are not, spoiling or ruining, anything with regards to the Bluebook practice test. These should be thought of as just additional, practice questions to prepare to take the SAT. And of course, there'll be a link in the description in the pinned comment to where you can download these questions, either just the unique ones or where you can get the whole entire test as well. All right, so let's get started with Module 1. If you notice, since these were grabbed a while ago, so these are actually all directly from the question bank as compared to the other linear paper practice test unique questions, which basically I have via screenshot because I grabbed them as soon as the tests were released. So just be aware, that's why the formatting is a little different here. So this first question, this is number 3, by the way, so you can see the module and question number up here in the upper corner for each of these. Okay, so what's the solution to this given equation? Well, all we have to do is just take 36 and just multiply it by 25, and that will give you 900 on the right side. But of course, we're solving for x, not x squared, so we do need to remember to square root both sides, and x is just going to equal 30. Okay, so the correct answer for this is going to be letter B. Now, of course, since this is an equation, we could just go to Desmos and type it directly in to Desmos. Now, we don't see any vertical lines because we have to zoom out, and right here, positive 30, negative 30, of course, the answers are all positive, so we want positive 30. So that's just an alternate way you could solve this one. Next up, it is question number 5. So here they give you this linear function, and you're basically asked to interpret what the number 25 means here. So notice um, T is the number of monthly deposits. In other words, T is how many deposits have been made. And the function overall is giving the total amount of money in the bank account. Okay? Right here. Function f of t gives blah, 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 amount in dollars in Hannah's bank account. So 25 times t has to equal a total number of dollars. Okay? T is the number of deposits. Therefore, 25 is how much she's depositing each month. So the correct answer for this is just going to be letter A. Basically think of this, 25 is just the slope, right? It's the change in y over change in x. So for each additional deposit, the amount in the bank account is increasing by $25. And so that's basically what A, literally says right here. Next up, question number 10. We have a scatter plot. We have a bunch of points on it. And we want to know which of these would be basically the equation for the best fit line. That's what this appropriate linear model says. So first, notice that if you just sketched out something like this, okay, that the y-intercept is going to be somewhere up here near 10. Maybe it's a little over 10, maybe it's a little under 10. But the point is, the y-intercept is not going to be 0.9. Okay, 0.9 is way down here. So this and this are obviously wrong. Also notice the slope is negative. Therefore, by process of elimination, the answer has to be letter D. Now, of course, you could still go to Desmos and solve the problem in there. So let's just say I'm going to pick 2 points. Something that looks, let me actually draw just like a slightly more accurate line. So like maybe something like this might be a little more accurate. So, okay, right here, 2.7, that looks pretty good. And like maybe 8.2. So to go to Desmos, I put those 2 points in. Now I can just click the Add Regression button here. It'll give me a linear regression automatically. And so now you're just looking at the answer choices for which have the closest values to this. So like negative 0.83, obviously for the slope, negative 0.9 is closest to that out of all these possible answers. Same thing, 8.667 y-intercept, positive 9.4 is going to be closest to that. So this just confirms correct answer is letter D. All right, next up, question number 16. Here you have another interpretation question, except this time it's with an exponential function. So they want to know here about, f of 5 is approximately 243. What does this mean? So notice, 5 is inside here, so 5 corresponds to x. Okay, what does x stand for? Well, it tells us x is number of years after 1957. So that means in our answer, we're looking for like either 5 years after 1957 or the actual year itself, i.e., 1962. So we're looking for one of those. So when you start going through these, you'll see the only one that mentions that is this right here, letter B. And then the 243, that's again, the function models the value in dollars of a certain bank account by the end of the year. So this 243 just means there were $243 in the account, again, after 5 years, i.e. 1962. So correct answer for this is letter B. Next up, question number 18. We have a square, and its side length is x, square p. We have a second square, and the second square has a perimeter 176 inches greater than the perimeter of the square. So, okay, we have the second square q. So notice the perimeter of the first square is just going to be basically 4x. Just add them all up, or just side times 4 is the shortcut formula. So this perimeter is 176 inches greater. You divide that by 4 because it's going to be split up as split up evenly among all 4 sides. So the extra 176 inches is going to be an extra 44 sides on each inch. So like x plus 44, x plus 44, all the way around. So what is the area of the larger square, square q? Well, it's just x plus 44 times x plus 44. Therefore, correct answer for this one is just going to be letter A. Now, just so you know, you technically could also do picking numbers for this. You could say that square p has sides 1, 1, 1, 1, and then you could say square q basically, so that, excuse me, the perimeter of this is 4. The perimeter says 176 is greater than. So you add 176 and you get 180, right? Then you divide 180 by 4. Therefore, each side has to be 45. Therefore, the area of Q is 45 times 45. What is 45 times 45? I think it should be 2025, but let's just go to Desmos to confirm. Yep, 2025. Okay. So now you would just go through the answer choices and you just type them each in and you would see which answer choice when x is equal to 1 is 2025. Okay, obviously it's A, and you can just double check that the others are not going to be correct. They're all going to be way too large. So that's how you could technically do this problem by picking numbers. Next up, question number 19. Here we have a function which relates x and y and w. And we want to solve this for w in terms of x and y. So the way you would do this by hand is you would first, well, actually, I'm going to simplify this first. I'm going to just turn this into 2 over 1 because 7 divides into 14 evenly. And then I would divide both sides by 2. And notice here 2 over 2 just cancels. So you get x over y equals this. Then I would square both sides. And we get w plus 19 equals x squared over y squared, and then I would subtract 19. So the correct answer is going to be x squared over y squared minus 19. Technically in choice C, they have it written in parentheses, quantity x over y squared, but that's the same thing, doesn't matter. Um, you can do it, you can just rewrite it that way as well. So the correct answer is letter C. Now, an alternate way to solve this would be to go to Desmos, use the strategy of picking numbers, and use regression. So here is what I mean. I am going to do 14x1 over 7y1 tilde 2 square root w plus 19. Okay, except now what I'm going to do is I'm going to define x1 as a number. All that matters is that it's positive because it says in the problem w, x, and y are positive real numbers. So I'm going to define x1 as 2. Then I'm going to define y1 as 3. Okay, so notice once I've done this, it has told me that w is negative 18.555555, whatever, rounds to 6. So now what I'm going to do is I'm going to type in the answer choices. It's a little annoying because you have to type x1 and y1. And I'm going to see, does this answer choice equal the value of w from the regression statement? So does it equal it? No, it's not negative 18.5555. It's pretty close, but it's not quite correct. Now I'm going to change this to 28 over 14. That is not correct. Let's see. Now I can get rid of this. I can send this back here. I can raise this. Notice I have the exact same value now. This confirms that letter C is correct. So this is how you could do this problem of solving a formula for a letter using regression and basically regression and sliders, and essentially it's like the process of picking numbers. All right, next up, question number 21. So here you have two expressions, and these are equal to ax to the b, where a and b are positive constants. Okay, x is greater than 1, blah, blah, blah. What is the value of a plus b? So the way to do this by hand is basically to first rewrite each expression in rational exponent form. So this 3 to the fifth root of that becomes 3 to the 5 over 5, and then x becomes 45 over 5. And then we have 2 to the 8 over 8 from the 8th root here, and then x to the 1/8. So notice 8 over 8 is just 1. 5 over 5 is just 1. 45 over 5 is just 9. So we have 6 times 3 is 18 times 2 is 36. And then here we have x to the, well, it's 9 plus 1/8. So you could just go to Desmos and do this, or you could do the fractions, and it's 72 over 8 plus 1 over 8. It's 73 over 8. So this is your A, this is your B. We're just going to add 36 plus 73 over 8. That is our answer that we're looking for. 45.125. What you have to be careful with now is you're only going to be allowed to fill in 5 spaces, 5 characters on the test. So you would either type 45.12 and then that's it. It wouldn't let you type anything else. That's if you truncate it. Or you could type 45.13 if you round it. Or you could put in the fraction form of 361 divided by 8. That would still allow for 5 characters. 361, why did I write a 5 there? That's completely and totally wrong. And I wrote 316. All right, just get rid of this whole thing. It's 361 over 8. Okay, so either of these three would be acceptable. Now, you could also do this in problem entirely in Desmos, basically using regression and essentially by matching the coefficients. So here's the way it's going to work. You're going to type in the entire first expression. Now, the shortcut way to get like a 5th root and an 8th root is you type nth root. And then I can make it a 5th root and say instead of a square root that you're typically used to, or even a cube root. And then, no, we need times. We need another root, but it's an 8th root. to the 8th x1 tilde a x1 to the b. Okay, notice it's actually giving us the correct value of a already, but it's not giving us the correct value of b. Let me just, yeah, because notice x has to be greater than 1. So what we have to also do is we have to define x1 as a list. That will end up giving us the correct value of b. And I'm not going to use 1. I'm going to use numbers greater than 1. So I'm just going to put 2, 3, 2 and 4 here. 3, 4. Okay, we already have the correct values. And now all you have to do is what's the value of a plus b? Well, a plus b right there. Again, we got the exact same answers, fraction form or decimal form. So this is how you could use regression to basically match two expressions together to find the coefficients and then, just add them together to get your final answer. Next up, we have a triangle. And they tell us the side lengths and they want to know the area of this triangle. Notice it's a right triangle. So of course, with a right triangle, we can just use, 1/2 base times height, since there are two sides, two legs that are perpendicular. And here you just have to know which two are the legs and which is the hypotenuse. So it's going to turn out, this is root 80, which could also be simplified to 4 root 5, that it's going to be set up like this. If you weren't sure, you just go to Desmos and you just type in, 6 root 2 versus root 80, and you see which gives you a larger decimal. And that's going to be your, your hypotenuse. So it's just going to be 1/2 times 2 root 2 times 6 root 2. That'll cancel. We get a 6. Root 2 times root 2 is just root 4, but root 4 is just equal to 2. So the correct answer for this one is going to be B12. Again, this multiplication with radicals, you just do that whole thing in Desmos if you don't want to do it by hand. You know what I'm saying? So you just do 1/2, and then we have 2 square root 2, 6 square root 2, and there's our answer 12, okay? So correct answer is letter B, 12. Next up, number 26. Here we have a question that has had very similar questions appear in some of the current Bluebook practice tests. It's not the identical numbers, but it's basically the same exact problem, just the numbers are different. So, still going to go through it because it's good to know how to do this. And easiest, fastest way to do this, type the equation of the top line in Desmos. You do not need to type the second equation. The second equation is the same as the first equation. It's just, everything's multiplied by 3. So it's infinite solutions. You're not going to get two different lines. Then type a bunch of points. Well, actually, first I'm going to add a slider and then type a bunch of points. Get rid of this. R over 7. And you're going to see which point, as I move the slider. All right, let's see. Okay, yeah, now it's not giving me the, otherwise, by default, it would just give you a circle. But okay, now it's not selected, so I guess I could have just done that from the beginning. 9/7, comma R. All right, we can label these A. We can label this B. 7 R plus 9, comma 8 R over 7 plus 27. Label is C. R over 3 plus 9, comma negative R over 3 plus 27. Let's label this D. So now I'm going to zoom out. Okay, C and D are nowhere close, so we can just ignore them. Now, as I move the slider, notice A stays on the line, but B does not. B appears to be on the line for certain values of R, but for every value of R, A is the only one that stays on the line the entire time. So the correct answer for this problem is just letter A. Next up, we have the last question from Module 1, Linear Paper Practice Test number 4. It's number 27. This one is one that you can also solve in Desmos or by hand. First, I'll show you how to do it by hand, then I'll show you how to do it in Desmos. So you have an exponential function here. They give you the general form of it. They tell you that basically this new function has an intercept here, and the product of both a and b is this, blah, blah. Okay. So we know AB is 65 over 7, and we know, okay. So basically, this y-intercept value right here is what you get when you plug in this x and this y to the original function, except it's also going to be shifted down 15 units. So in other words, negative 99 over 7 is equal to negative a to the 0 plus b, but you also have to add a minus 15 at the end because of this whole thing here. It says y is equal to f of x but minus 15. So I'm taking this function really and I'm plugging in the x and the y into it, and I'm solving now for, basically I'm going to end up solving for b. Because what happens is if you add 15 over here, you are going to get, let me just look at my notes here. I believe it is should be 13 over 7. We'll just go to Desmos to confirm in a second. A to the 0 is 1. So this is just negative 1 plus b. Wait, 99.7. Actually, no, that's not what that's what you get at the very end, after you combine it with the minus 1. So let me just start like this. Negative 99 over 7. Okay, we're going to add 15 to it. What's the fraction? 6 over 7. So initially it's 6 over 7. Then we're going to add 1. That's what is going to be the 13 over 7. So b is equal to 13 over 7. Now you can take that, you can plug it into this equation because the product of a and b is this. A times 13 over 7 equals 65 over 7. Here, basically, the 7s are going to cancel, and then you're just going to divide both sides by 13. And you get a equals 5, which is the correct answer. Notice for this step also, you could go to Desmos, and you could just do that using regression. So in other words, you could just type a times 13 over 7 tilde 65 over 7. Let me just slide up, and right there it gives you a equals 5, okay? So you could do that just to solve the last step in Desmos. Now, here is how you could solve this completely by using the Desmos graphing calculator. So let me jump over here. So what I'm going to do is I'm going to enter a table, and I'm going to put in this. Now, I am also going to note, so like if I want to type in the regression, right, it would be negative a to the x1 plus b, except there's two things I need to change here, or things I need to do. Okay, first I need to account for this minus 15. So notice if I'm going to basically do a regression on this version of it, like I either need to add 15 to the y-intercept, or I just need to put a minus 15 at the end here. Okay? Because really what I'm doing is I'm doing a regression on this right here. I'm doing y1 equals negative a to the x1 plus b minus 15. And then this is the point I'm using. Okay, so I have that. So that's the first thing I need to take care of. The second thing is here, you have only 1 point, but you have 2 constants. So you can't get a good answer, an exact answer for 2 constants doing that. So what I'm going to do is I am going to basically take the AB equals 65 over 7, and I'm going to solve it for B. And I'm going to get that B is equal to 65 over 7A. Then I can replace that in here. Delete this. Now it's only in terms of A, and now it gives me the value for A, which is what I want. So right here, A is 5, and that's it. So again, this is how you could do this entire problem in Desmos using regression. All right, so now let's go ahead and move on to module number 2. So we are here at the beginning of module 2. It's question number 2, and we have a just basic unit conversion. 5,104 yards, and we want to convert this to miles. They give us the conversion. 1,760 yards is 1 mile. So the yards will cancel out. We can just multiply these. The answer is going to be 2.9 if you just divide these in Desmos. So the correct answer for this is just letter B. Next up, question number 3. So which of these expressions is equivalent? Here we're just subtracting 12 minus 5, 7. Subtract the coefficients, keep the same variable. 7x cubed. Correct answer is letter C. I will mention briefly, I'm not going to bother to show it, that you could type this into Desmos, and then you could go through and type all the answer choices, and you can see which one overlaps to confirm that it's correct as well. Just so you know, you technically can do that. All right, next up, question number 7. Here is a basic linear function, and they want to know is basically when x is 7, what's the total number of people? So in other words, you're plugging in 7 to this function. They're basically just asking what's f of 7. So, well, it's just 49 plus 1. It is equal to 50. Correct answer for this you would grid in is the number 50. Next up, question 14. You have this line which is parallel to line J. This line here is parallel to line J. What's the slope of line J? Well, it's going to be whatever the slope of this line is because parallel lines have the same slope. So the slope of this line is just 2. Therefore, the slope of line J is also 2. So the correct answer for this would just be 2. That's what you would grid in. Next up, 17. In this equation, P is a constant and it has no solution. What is the value of P? So the way to solve this by hand is to notice that in order for this to have no solution, these two terms need to cancel out, meaning the coefficient on the x terms here has to be the same, i.e. negative 3 must equal 21p. So, actually no, sorry, let me restate that. That was incorrect. In order for this to be no solution, these two terms must cancel out, which means the coefficients on these x terms must be opposites. In other words, like this has to equal negative, this equals negative 3, therefore this whole thing has to equal positive 3 in order to cancel. So the correct answer is going to be 3 over 21 or just 1/7, letter B. Now, of course, you could just go to Desmos and just type all these in. And here's the thing to be careful with. The way I would look at this is I would type y equals left side, y equals right side. Okay? Now you're going to have to zoom out a ways because it's like way up here. Here's the y equals 84 line. And then we're going to add the slider for p and we're just going to type in the various answer choices. So does this have no solution? No, it intersects right here. It does not have no solution. It's not the right answer. Does this have, let's see, did I not type something? Oh, it should be plus, not minus. So let me go back and redo the first one. Okay. Does it have no solution? No, it intersects here. It does not. Does this have no solution? Yes, we have two parallel lines, basically two horizontal lines that do not intersect. So that just confirms it's the correct answer. You could try the other letters as well, but you can see the other answer choices were all going to intersect at least one time. Next up, question number 18. For what value of x does this function reach its minimum? So the way to do this by hand is to notice that the vertex for any quadratic function here is basically symmetric or directly in the middle of your two x-intercepts, meaning if you take your two x-intercepts and you average them, that's going to give you the x-coordinate of your vertex, which is what they want here. So this has an intercept of 10. This factor corresponds to an intercept of negative 13 because technically you set each factor equal to 0 and then solve it. So 10 plus negative 13, we're going to find the average of them, divide by 2, negative 3 over 2. That should be our correct answer, which is letter D. Now, the other way, obviously, you could do this, which you might find quicker, is just go to Desmos, graph out the function. Let's zoom out. Where's the minimum? It's right here. What is the x-coordinate? It is negative 1.5. Now, you could then just type that and click on this to convert it to its fractional form, -3/2. So that's just how you could use Desmos to get it as well. Next up, question number 21. So this equation has no real solution. What is the greatest possible value of b? The way that you solve this by hand is you look at the discriminant, from the quadratic formula, b squared minus 4ac. So for this case, it's going to be, and you essentially have it less than 0. So b squared minus 4 times -1 times -676, or in other words, b squared minus 2704 is less than 0. B squared is less than 2704. Technically, the way you solve a quadratic inequality is you have to replace this with an equal sign and use that to get your critical points. In other words, square root both sides, and b is going to equal 52. And then you make a number line. All right, so basically now, when you plug in values for b squared, you're looking for, is it these values in here, is it less than 2704 or is it more? So pick 0, okay? Obviously, if you plug in 0, 0 is less than 2704, so that works. If you pick numbers like -55 or +55 and you square them, they are going to be, see, 3025, it's greater than it, the 2704. So these are not going to work. So the solution set is basically from -52 to +52, not including the endpoints, because the endpoints would equal, which means there would be one real solution. So what is it asking for? What is the greatest possible value? So the greatest possible value in this interval is going to be 51. And notice also it tells us it's an integer, okay? If it didn't tell us that, then then you really couldn't answer this because it'd be 51.9999999 whatever repeating. But because it tells us it's an integer, okay, it's not 52, it's going to be 51. So that's what you would grid in. That's how you could solve this by hand. Now let's jump to Desmos. Okay, so let's delete all this. Here we have our equation. Let's add a slider for b, okay? Let's zoom out. All right, let's just jump up here. Yeah, see, okay. So I was at 6. First of all, I'm going to set the step value at 1 because I only want integers. Notice I don't see anything when I'm way down here at 6. All right. And why don't I see it? Well, that's because it's way down here, the vertex down here at -667. So you got to scroll up, a ways. Oh, so now you're basically looking for what's the highest value I can make b such that it does not cross the x-axis. So 51 it does not cross. 52 it does cross. Well, I mean it touches, but it gives a real solution. Therefore 52 is not the answer, but instead it's 51. So that's how you could solve this in Desmos just using a slider. Next up, question number 52. Not 52. What am I talking about? 22. Let me just there you can see the number at the top and we get all the answer choices on the screen. Okay, so we have two equations graphed here already. They say that they're making a third system of equations using these two plus this right here. How many solutions will there be to this three line system of equations? All right. So there's a couple different ways you could think about this. The way that I looked at this is I started, okay, so first I'm going to call this I'm going to call this line 1, I'm going to call this whatever, line 2, and then this down here is line 3. Okay? So the first thing I did is I said, okay, let's see line 1. So I'm going to pick the 2 points that are on it, -4, 5, and it looks like 8, 2. So let's do a regression and let's get this line. Okay, so this is line 1. Now I'm going to graph line 2, which is just the horizontal line y equals 2. All right, so we have this. They're intersecting here at 8, 2, so that checks. Now let's look at line 3. Okay, notice line 3 is going to end up being parallel. It will never intersect line 1. So how many solutions is this system going to have? Well, the answer is just going to be 0, none. Now, the way I know that too for sure is that line 3, the slope, just negative a over b, negative 1 over 4. It's negative 1/4. For this line, for line 1, notice the slope, I can just get it by counting. It's down 1, 2, let's see here, 3, and it's over 1, 2, 3, 4, and then plus 8 more to the right. So it's over 12, and it's down, what did I say? Down 3. Yeah, it's going from negative 5 to negative 2. So this slope is also negative 1/4. So these two slopes are the same. Therefore, line 1 and line 3 will be parallel. They will never intersect. So therefore, the number of solutions for these three equations will be 0. Next up, let's look at number 25. Here is the equation for a given circle. Then we take the circle and we shift it down 2 units. Which of the equations represents circle B? So, a couple things. First, I will explain actually, first I'm just going to demonstrate it in Desmos because I think that's probably the way most people would think about it, or the easiest way to do it. Then I'll explain the theory behind it. So I have my original circle. Okay. Now, let's go through our answer choices. Okay, is this shifted down 2 units? Again, that's what we're looking for. Shifted down 2 units. No, it looks like it's shifted to the right 2 units, but definitely not down 2 units. Okay, so that's wrong. Let's check out B. So now we just change this. Is the blue shifted down 2 units? No, it's shifted up 2 units. Okay, so that's wrong. Let's go back to C. Shifted down 2 units? No, looks like it's gone to the left by 2 units. Okay, let's go to D now. All right, here we have a circle, the blue one, which is shifted down 2 units from the red one. So the correct answer choice for this problem is letter D. Now, here is why the answer is letter D. So, the reason is because you are basically, the y is in parentheses, and anytime you have a variable that's essentially like in parentheses, when you're looking at doing a shift, you have to do the opposite. So what I mean by that is, think about a basic parabola, or any type, whatever, any type of function you have here. It's like, say you have like f of x equals whatever. It's like 2x squared minus 4x plus 1. Okay. And then I say, I want to shift this 5 units to the right. Okay. Technically, the way you would write that is you would say f of x minus 5. If you want to shift, and you replace every x with an x minus 5. Okay. This is corresponding again to a shift 5 units to the right. Normally, though, when you do an up or down or vertical shift, you write it as like, f of x, say, plus 5, or f of x minus 5, where it's outside the parentheses. Okay? And you would just, add a 5 onto the end, or do a minus 5 onto the end. In other words, it's like the same value. If you're shifting up, it's a plus, and down if it's a minus, as compared to horizontal shifts, where to the right is a minus, to the left is a plus. However, that's not the case for circles because the y is also in parentheses. So that means when you want to shift down 2 units, you're not going to put a minus 2 in here. You're technically going to put a plus 2 because the fact that it's in parentheses means it's the opposite. So when you do that, it makes this parentheses into y plus 1, and that's why it's letter D. Okay, so that's the theory behind it. Now, one other thing just keep in mind, another easy way to do this without actually graphing them is to just, if you know the standard form equation, if you're familiar with that, notice this circle has a center of 0, 1. So if you're at 0, 1 and you go down 2 units, you're again going to be at 0, -1. So just go through all these answers and see which of these has a center at 0, -1. Okay? Well, it's not A because A is going to be 2, 1. It's not B because B is 0, 3. It's not C because C is -2, 1. Okay, it has to be D. 0, -1 right here. So that's another easy way to think about it. Might be easier than graphing them all out and quicker than it if you're familiar with the standard form equation of a circle and identifying the center. All right, next up, the last question from Module 2, number 27 on this linear paper practice test, number 4, deals with percentages. So 210 is p% greater than 30. What is the value of p? So essentially what you have going on here is you have 210 is equals p% greater than 30. So that means we're taking 30 and we are adding to it p% of 30. Okay? So it's not, you have to be careful. A lot of people set this up and they think it's 210 equals like p% of 30, which means it's just 210 equals p times 30. That is not the case. It is 210 equals 30 plus, p% of 30. So if you go ahead and solve this out, just think about this, whatever, in terms of p, treat this as your variable. You get 180 equals 30p, p equals 6. Now, this is the number in decimal form, but to convert it to an actual percentage, because the p here represents a percentage, you must multiply by 100. The correct answer is 600%. Now, you could also, of course, go to Desmos. And we should be able just to type the whole thing in here. 200, we don't want is, p%. Let me see. What's 30? Does this work? No, let me try. Oh, I have to use X. That's what the issue is. Let's see if this gives us the correct answer. Yep, there it is. X%, so you have to use, you have to remember, you got to use X, you can't use P. X% of 30 greater than, more than 30, I mean, you could add the 30 in the front if you wanted to, equals 210. And notice this equation gives me a vertical line at 600, which is what we're looking for. It's basically already taken the p-value and converted it into its appropriate percentage, which is 600%. All right, so I hope you enjoyed this video covering the answers and solutions to linear paper non-adaptive practice test number 4, the unique questions from both modules 1 and module 2. If you have any questions or comments or alternate solution methods, please do feel free to leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And also check out the solutions to the unique questions on the other, linear non-adaptive paper practice tests. And lastly, if you're looking to, improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It features over 3.5 hours of tips, tricks, instruction, and 45 practice problems to help you ace the digital SAT Math section using Desmos.